Hey, welcome back. I just wanted to try a few more of these with you to guide you as you're practicing finding these exact values of trig functions using the unit circle. It's nice to have the unit circle in my back pocket, especially quadrant one. If I look at a question like number 10, what's the cosine of 11 pi over 6? Step one, let's draw the angle. So 11 pi over 6 is, think in radians now. You're almost all the way to 2 pi. You're almost to 12 pi over 6. You're just pi over 6 short of that. Your theta prime, your reference angle can be pi over 6. Remember, you can always get a reference angle in quadrant 4 using 2 pi. If you take 2 pi minus 11 pi over 6, that'll get you your reference angle of pi over 6. Plus, you have that nice shortcut in radians. If your original fraction is a fraction of pi divided by 6, you can be confident that your reference angle will have the same denominator. And you're usually choosing between pi over 6, pi over 4, and pi over 3. Well, here we are in quadrant ASTC, where cosine and its reciprocal happen to stay positive. So there's no need to put a negative sign by this one. We can keep it positive. And then I think to what I've written at the top of the page, or just quadrant 1 of the unit circle, for pi over 6, you're going out further than you're coming up. So square root of 3 over 2 should come first as the x value. In our simplified trig function definitions, cosine is just the x around the unit circle. So it's just going to be square root of 3 over 2. Okay. Don't let a huge angle like 25 pi over 6 get you down. I can tell you right now confidently, I'm not so sure about the quadrant yet, so I don't know if I should put a negative sign by it, but I can bet the reference angle is going to be pi over 6. Well, let's subtract 2 pi from this. Let's find something coterminal. So if I subtract 2 pi, subtract 12 pi over 6, I'm down to, I think, 13 pi over 6. And if I subtract 2 pi again, another 12 pi over 6, I'm down to just plain old pi over 6. Number 11 actually lands in quadrant 1. You have a coterminal angle that's just pi over 6. In quadrant 1, so it's like you've gone around once, twice, and then a little bit more. You are positive like all the trig functions are in quadrant 1. And the sign, I have this diagram here, this time is the y value. So the sign is just going to be a half. Okay. Something else that's quadrantal, 3 pi, where would that fall? So 3 pi is going to be over 1 pi, 2 pi, 3 pi. It's coterminal with pi, so this should exactly equal the cosecant, of pi. And cosecant, I got to think to myself, this is quadrantal, so the units that would get me over here on the unit circle would be negative 1 comma 0. Cosecant is the reciprocal of that y value. So instead of being 0, it's going to be 1 over 0, or actually undefined for number 12. So that's what this is all about, a bunch of practice with these exact values. There's one other type of question that you'll see, and it's a few pages ahead. You've got to turn all the way over, a few pages ahead, to page 21 of the packet. And I wanted to end on these angle questions. These are some good ones. These actually flip it around on us. It's not asking me for the cosine of an angle because it gave me the cosine. It's saying what angle or angles in the interval from 0 to 360 degrees, so we know we're allowed to answer in degrees here, would have a cosine of the square root of 2 over 2. We're going to try to figure this out exact value-wise. Well, do I have a couple options around the unit circle? In which quadrants, right, do we have cosines that are negative? If I think A, S, T, C, I believe quadrant 2 has cosine being negative there, and quadrant 3 also has cosine as a negative. So 7's a good question, and we're going to get 2 answers around the unit circle on the interval from 0 to 360. Let's figure out a reference angle. That would be good too. So think about the cosine being negative here. Think about whether it would be 30, 45, or 60 so that the cosine would be this number. And if I'm filling in the values, what is it? Square root of 3 over 2, square root of 2 over 2, and then square root of 1 over 2. I want 45 degrees as a reference angle for this one. 45 degrees would have a cosine of the square root of 2 over 2. And I squeeze it into that little reference angle spot. That's the acute angle between our terminal side and the x-axis. Now to get our solutions, right? So we know theta prime equals 45 degrees. I'm not so sure that's an actual solution for theta though. We need an angle that would correspond to this that's in quadrant 2 and another angle that's way over in quadrant 3. 180 is going to be helpful for both of these solutions. We could do 180 plus 45 degrees for the answer that's going to be in quadrant 3, and 180 minus 45 degrees could get us the answer that's in quadrant 2. So I'm liking 135 as a solution from 0 to 360, and then also 225. And actually, I believe I mixed up the signs here, right? The minus would give you 135, and the plus would end up with 225. Try one more. 8 says, where would the secant of theta equal 2? Think about this one for a sec. So secant of theta equaling 2, where are one or two quadrants where the secant would be a positive number? So secant, it corresponds to its reciprocal. Maybe I'll change this and I'll write, I know if the secant is 2, its reciprocal, the cosine, should equal a half. This might be an easier starting point. Well, that tells me I got to think ASTC, where is cosine going to be positive? Should be the exact opposite two quadrants of the ones we got in number 7, where it was negative. All trig functions are positive in quadrant 1, and cosine and its reciprocal secant are also positive in quadrant 4. So let's get a reference angle, and we could see if we get 2 answers for this one as well. So reference angle, I have the x values written in here in quadrant 1 of the unit circle. I want the cosine now to be a half. So I like a reference angle in degrees of 60 degrees. I'm going to squeeze that into the reference angle spot here and there. And let's see if we can get 2 solutions. One solution that's in quadrant 1, so theta equals just plain old 60 degrees, would make a true statement. And then how about another one that's way over in quadrant 4? So you're 60 degrees shy of 360. I'll call this the second. Maybe I should call these theta sub 1 and theta sub 2. Second answer, 360 minus 60, 300 degrees. Another thing to look out for, if you see, there's trig notation we haven't talked too much about yet. If you see the squared notation, this is a good thing to mention. All this means when that 2 is on the inside, right, it's easier to write this as the sine of 135 degrees squared plus the cosine of 135 degrees squared. If you feel confident that you can find exact values for these 2 things, it should be just as easy to square those values that you get. So let's try 135. Sine of 135, here it is in quadrant 2, should equal the same thing as the sine of its reference angle. Should equal the same thing as the sine of 45 degrees. Put that there. And it is in quadrant 2 where sine is positive. We'll end up squaring it. Plus the cosine, same reference angle, of 45 degrees. But since we are in quadrant 2, technically cosine is negative there. I don't see that affecting our answer too much since we know we're about to square both parts of this. So look at your unit circle, or see if you're remembering. The sine of 45 is the square root of 2 over 2. We've got to square that. Plus the cosine of 45 negative is negative square root of 2 over 2, which is going to get squared as well. So what do we have? Square the first fraction, square root of 2 squared. So 2 over 4 plus another 2 over 4, right? A negative squared should give you a positive. So 1/2 plus 1/2 is going to equal 1. Just something to look out for, and we can talk about this more in class, the notation with the square being on the inside of the writing there. All right, I appreciate you tuning in. I cannot wait to hear your questions, and I hope you have a great day. I will talk to you soon. Thanks.